In this video, we'll continue our discussion of higher partial derivatives by working out another example. All right, so we have this function. We have the inverse tan, which is going to make things gross, and then we also have a fraction inside that argument. It's just going to make things disgusting. All right, so we have those four mixed partials that we want to find. So let's find fx first. So, okay, x and y are considered inside the tangent, so I have to respect that. The derivative of tangent arctan is 1 over 1 plus the argument squared. So this is just y squared over x squared. Right? Times the derivative of the inside, but this is going to be the derivative with respect to x of y over x. I don't think I need this parentheses. There we go. Okay, so if I work that out, okay, I got 1 over 1 plus y squared over x squared times, okay, the derivative with that with respect to x is going to be negative y over x squared. Okay, so what this gets me is this is negative y over x squared over 1 plus y squared over x squared. If you wanted to clean this up, what we could do is multiply top and bottom by x squared. Since that thing in the parentheses there is a 1, we're allowed to do this. This is going to clean everything up. The x squareds cancel on the bottom. And I get negative y over x squared plus y squared. It's a nice, pretty answer. Okay. Unfortunately, though, that was only fx. Okay, so I'm going to shrink this down or move things around. Let's do this. Shrink it. And then I'm going to move each one of these over. Thanks for being patient. There we go. Okay, so that's fx. Let's go ahead and find fxx. All right, fxx, notice there's only one in the denominator. So what I'm going to do is think of the derivative, but I'm going to use this time to be able to rewrite this as this. There we go. Hopefully that'll help. It's a product rule. Really, we only have to do the derivative. The negative y is considered a constant, so it's not a product rule. It's going to be just a chain rule of that inside. Okay, so I got negative y. The negative 1 comes down to make a y. Then I got x squared plus y squared. I drop the power, so it becomes a negative 2. Then it is the partial of the inside. The partial of the inside will just be 2x. With respect to x, that's why the y squared is considered a constant, and it's gone. Okay, so what this gets us is we got 2xy, okay, and this is going to be over x squared plus y squared to the second power. Okay, we did that one. Now let's do fxy. And that'll cover 2 of them, then we'll do our fy's. Okay, so we're back to here. Oops. Go right here, and we got to take a derivative with respect to that. This is going to be a quotient rule, or we can do a product rule. Let's do a product rule. So it's the derivative with respect to y of that same thing that we just wrote just above. All right, this is a product rule, so it's going to be the derivative of the first thing times the second plus, so negative y times the partial with respect to y of the other thing, which is x squared plus y squared to the negative 1. Okay, so the partial of just negative y is negative 1. So we got negative 1 times x squared plus y squared to the negative 1 minus, okay, and I'm going to have a y. And now I got to take that derivative, so the negative 1 comes down. X squared plus y squared stays to the negative 2 times 2x, or it's with respect to y, so it's going to be 2y. The x is gone because it's a constant, and that's what we're left with. Okay, so let's try to get this down to something that doesn't look absolutely horrible. We have that, and then we're going to get a positive, and then this numerator is going to be a 2y squared over x squared plus y squared to the second power. You could even, if you wanted to, combine those by multiplying the left one with x squared plus y squared. So we're going to get a negative x squared plus, let's flip these to make it prettier. we're going to get y squared minus x squared over x squared plus y squared squared. You don't have to go that far. You could stop right here when all the calculus is done. But I kind of like going that far as a mathematician. You may feel indifferent. There we go. So that's fxy. Now, I am going to cheat here. I have fxy, and I can also find fyx. Fyx is going to be the same exact thing. As long as our partials were continuous on a region, well, our partial was right here, and it is continuous everywhere except for x and y equaling 0, but even our original function, x couldn't be 0 anyway, so we're okay. As long as, and y could be 0, as long as x is not 0. Okay. So we have those two. Let's highlight the ones that we have found. I have this one, I have that one, and then we also have fxx. The only thing that's remaining is we got to find fyy. So let's do that. Fy first. So looking back at our function, I got to zoom out here. We have the inverse tan. So okay, we get that same thing that we got above there. X squared. And then now we got to do the partial with respect to y of the inside of that original y over x. All right. This is equal to 1 over 1 plus y squared over x squared. And then that derivative, let me zoom back in here. Let me fix my handwriting there. I got really bad. Oops. All right, so we get 1 over 1 plus y squared over x squared. It's not much better. And then times the derivative of y over x with respect to y. That's just 1 over x because that's the constant times y. This is equal to 1 over x over 1 plus y squared over x squared. This is that same technique. I can multiply by x squared on top and bottom, leaving me with x on top over x squared plus y squared. So there's just y. And now we got to do fyy. That is my partial with respect to y of that function. Right? I'm going to write it that way to help ourselves out. X is a constant in this case, so all I got to do is keep the x. Okay, multiply by -1, x squared plus y squared. That goes to a -2, and then I got to take the partial of the inside with respect to y, so it's just going to be a 2y. So we get -2xy over x squared plus y squared over 2. Now, we could probably compare this to the other one and see how it played out, and we probably could have came up with our answer for that other one. Let me write it here. fxx. I'll scroll up and write it down. Where'd it go? Okay. It is 2xy over x squared plus y squared squared. So there's our other one we can compare. So the difference in those two was just negative. I don't know if we could have seen that or not, but sometimes you can look at fxx and fyy, and you can see a pattern in between them, meaning when you find xx, you can think about it and find yy by making it, they're symmetric. They look identical. All right, so those are higher derivatives. They can get nasty. I recommend just writing out as many steps as you can.